Lesson 9.3, Solving Rational Equations. Essential question: what are the methods for solving rational equations? They can be solved either algebraically or geometrically. So they can be 1, algebraically, or 2, graphically. Solving rational equations graphically. A rational equation is an equation that contains one or more rational expressions. The time t in hours it takes to travel d miles can be determined by using the equation t equals d divided by r, where r is the average rate of speed. This equation is an example of a rational equation. One method for solving rational equations is by graphing. So we're going to solve the rational equation x divided by x minus 3 equals 2 by graphing. A, the first step is always determine or identify any excluded values. A number is an excluded value of a rational expression if substituting the number into the rational expression results in a division by 0, which is undivided. For example, here in the denominator you have x minus 3. So we're going to set that equal to 0 and then solve for x. Add 3 to both sides and you get x equals 3. So your excluded value is 3. Rewrite the equation with 0 on one side. So basically we're going to subtract 2 from both sides and we get x divided by x minus 3 minus 2 equals 0. X divided by x minus 3 minus 2 equals 0. Graph the left side of the equation as a function. Substitute y for 0 and complete the table below. Okay, so you have x over x minus 3 minus 2. So we're going to put a 0 in for the x, so you got 0 over 0 minus 3 minus 2. Well, 0 divided by 0 minus 3 is negative 3. 0 divided by negative 3 is 0, and 0 minus 2 is negative 2. So that's going to give you the order pair 0, negative 2. So we got 0, negative 2. That's going to be right there. Now let's put a 1 in there. Let's put a 1 in there. So you got 1 divided by 1 minus 3. Well, 1 minus 3 is negative 2. So that gives you negative 1/2 minus 2. And that's going to give you negative 2 and 1/2. So we got 1, negative 2 and 1/2. So that's 1 and then 2 and 1/2. That's going to be like right about in there. So that's that, and that's that. And now let's put a 2 in there. Let's put a 2 in there. Well, 2 divided by 2 minus 3 is, well, that was 2 divided by negative 1, or negative 2 minus 2. That gives you negative 4. So we got negative 4 here. And we got, for an order pair, 2, negative 4. So 2, negative 4 is right there. All right, good. Let's try putting 4 in there now. Let's put a 4 in there. So we got 4 divided by 4 minus 3. So that's going to be 4 divided by 1. 4 divided by 1 minus 2. That's going to give you 2. So we have the order pair 4, 2. So let's find 4, 2 is right there. And now it wants us to put 5 in there. And we can do that. So we got 5 over 5 minus 3. So that's going to be 5 halves minus 2. Well, 5 halves is 2.5. So that's going to give us 1/2. So our next order pair is 5 and 1/2. So 5 would be right about there. And then 1/2 would be just up a little bit there. And next they want us to put in 9, so let's put in 9. Let's put a 9 in there. 9 over 9 minus 3. That's going to be 9 over 6 minus 2. Let's see, 3 goes into that. 3 and 2, 3 is. So that's 1.5 minus 2. So that's going to give you negative 1/2. So we now have 9 and negative 1/2. So 9 and negative 1/2 is going to be right below there. So you're going to have something that goes maybe something like this. And then you're going to have something that's going to go maybe something like that. I kind of missed them a little bit, but you get the hint. And that's what it looks like. Identify any x-intercepts on the graph. Well, it looks like it crosses here at 6. Okay, and that would be 6, 0. 6, 0 is the value of x an excluded value? No, 6 isn't. 3 is excluded, but 6 is not. So no, no, no. X equals 6 is not excluded. All right, now let's graph this in the calculator because this hand graph was not all that great. So let's go to graphs here and control divide, and you got x over x minus 3, and that's minus 2, and let's graph that. Okay, see, it does cross the x-axis about right there. And so let's see here, menu 6 and then 0, and there it is, 6, 0, which is what we had on ours. So that looks good. Reflect. Why does rewriting a rational equation with 0 on one side help with solving the equation? Rewriting the equation with 0 on one side helps because the expression on the other side can be graphed, and the solution is the x-intercept. So why? Because you can graph it. Because you can graph it. The equation, you can graph the equation, and the x-intercept, is the solution. Solving rational equations algebraically. Rational equations can be solved algebraically by multiplying through by the least common denominator and solving the resulting polynomial equation. However, this eliminates the information about the excluded values of the original equation. Sometimes an excluded value of the original equation is a solution of the polynomial equation, and in this case, the excluded value will be an extraneous solution of the polynomial equation. Extraneous solutions are not solutions of the equation. The reason why the excluded value would make the denominator go to 0, which would make it undefined. So we're going to solve each equation algebraically. So I'll let you look through A at your leisure and stuff, and then when you come back, we'll do B together. All right, glad you're back. B, you have 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. Step 1 is always identify the excluded values. So what do we have in the denominator? We have x minus 7 and 2. Well, 2 can't be made to a 0, but x minus 7 could be made to go to 0. So x minus 7 equals 0. Add 7 to both sides, and you got x equals 7. The excluded value is 7. Step 2, identify the least common denominator. Well, there are two different factors in the denominator. You have x minus 7 and you have 2. Okay? So the least common denominator is going to be 2 times x minus 7. 2 times x minus 7. Next, you want to multiply each term by the least common denominator. So we're going to put 2 times x minus 7, 2 times x minus 7, and we're going to multiply each one by 2 times x minus 7. All right. Divide out the common factor, so you got 2 times x minus 7, 2 times x minus 7, and 2 times x minus 7. So these cancel out, the 2's cancel out, x minus 7's cancel out. All right, what do you got? Simplify. You got 2x minus 9 times 2, so we got 2 times 2x. And here, the 2's cancel out, so you got x times x minus 7. The x minus 7's cancel out, so you got 5 times 2. Use the distributive property. So we're going to have 2 times 2x, that's going to give you 4x, and 2 times 9, that's going to be minus 18. Well, you got x times x, that's x squared, and x times negative 7, that's negative 7x. And here I put a 5, and I should have put a 2. 5 times 2 is 10. All right. Now it says, write this in standard form. Well, there's a couple things we need to do first. One, we need to combine like terms. 2, we need to put them in descending order. So what's the highest one? Well, I'm looking, I got x squared here, right? So I got x squared. And then I've got 4x minus 7x, so that's going to be minus 3x. And then I got a 10 over here, so I'm going to subtract 10 from both sides, and that gives me minus 28. Now that's in standard form because the exponents, 4 or 2, 1, and then 0. Right, good. Now, what's really neat about doing this is it puts it in a form that you can factor. So what are the factors of negative 28 that when you add them give you negative 3? And I get 28. What are the factors of 28? I get 7 and 4. So I've got x minus 7 times x plus 4. And that equals 0. So set each one equal to 0. X minus 7 equals 0. X plus 4 equals 0. Add 7 to both sides, you get x equals 7. Subtract 4 from both sides, you get negative 4. All right. The solution x equals 7 is extraneous because it is an excluded value. Remember, that was step 1. The only solution is x equals negative 4. All right, good job. Good job. Now it's your turn. Go ahead and stop the video and take a couple minutes and set it up and see what you can do with it. When you get back, we'll work it together. All right, I'm glad you're back. Step 1, find the extraneous solutions. 1, extraneous solutions. Extraneous solutions. What are they? Well, what do we have in the denominator? We've got x plus 3, set that equal to 0, and x plus 6, and set that equal to 0. So that's going to give you x equals negative 3 and x equals negative 6. All right, so the extraneous solutions are negative 3 and negative 6. Step 2, the least common denominator. All right, well, what do we have in the denominator? X plus 3, which is prime, and x plus 6, which is prime. So our least common denominator is going to be x plus 3 times x plus 6. All right, good. Now we're going to multiply the least common denominator by each one. So you got 8 over x plus 3 times x plus 3 times x plus 6 equals x plus 1 over x plus 6 times x plus 3 times x plus 6. Now, what do we got here? We got x plus 3 and x plus 3. We got x plus 6 and x plus 6. We got rid of those. And what's left? 8 times x, 8x. 8 times 6 is 48. Over here, x times x is x squared. X times 3 is 3x. 1 times x is 1x. And then 1 times 3 is 3. And you notice I can combine like terms here. So I got 8x plus 48 equals x squared plus 4x plus 3. Now I need to get everything on one side. So I'm going to subtract 8x from both sides. I got x squared minus 4x. And I'm going to subtract 48 from both sides. And I got minus 45. And that equals 0. Now we can factor this by hand because the factors of negative 45 that give you negative 4, when you add them, would be x minus 9 and x plus 5. So let's set those equal to 0. X minus 9 equals 0, and that gives you x equals 9. And then x plus 5 equals 0. Subtract 5 from both sides, and you got x equals negative 5. So our solutions are 9 and negative 5. I'm looking, neither one of them are extraneous solutions. So that is our solution. Great job. Solving a real-world problem with a rational equation. Use a rational equation to solve the problem. Kelsey is kayaking on a river. She travels 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, Kelsey can travel at an average speed of 3 miles per hour. What is the average speed of the river's current? Identify the important information. The answer will be the average speed of the current. The average speed of the current. Kelsey spends 6 hours kayaking. She travels 5 miles upstream and 5 miles downstream. Her average speed in still water is 3 miles per hour. Now we're going to formulate a plan. Let C represent the speed of the current in miles per hour. When Kelsey is going upstream, her speed is equal to her speed in still water. She's going upstream, so she's going against the current, minus the current, or C. When Kelsey is going downstream, her speed is equal to her speed in still water plus the current, because the current's pushing her. The variable C is restricted to positive real numbers. All right. Her speed cannot be negative. If it's negative, then she'd be going backwards and not forwards and all that other stuff. So let's set us up a table so we can figure it out. All right. Her speed, if she's going upstream against the current, would be 3 miles minus the current. If she's going downstream, it would be 3 miles per hour plus the current. Now, what about the time? Well, let's see here. Her distance was 5, and then her average speed was 3 minus C. And remember we said time was the distance divided by the rate on the other page. So that's where I'm getting this. And then you got 5 over 3 plus c. Use the results from the table to write an equation. So you've got upstream, that would be 5 over 3 minus c. And downstream would be 5 over 3 plus c. All right. Solve. Well, step 1 is find the extraneous values. And the way we do that is we look and see what's in the denominator. And you got 3 minus c in the denominator and 3 plus c. So if we add c to both sides, then we got 3 equals c. If we subtract 3 from both sides, we got c equals negative 3. So the excluded values are 3 and negative 3. The least common denominator is, well, what do we have in the denominator? We have 3 minus c and 3 plus c. So the least common denominator will be 3 minus c times 3 plus c. So we're going to multiply the entire equation by 3 minus c times 3 plus c. 3 minus c times 3 plus c. 3 minus c times 3 plus c. All right, here it says divide out common factors. So we got 3 minus c, 3 plus c. Nothing to take out there. You got 3 minus c times 3 plus c. And you can get rid of the 3 minus c's here. All right. And then you've got 3 minus c times 3 plus c. Again, you can take out, well, here you can take out the 3 plus c's. So what do you have left? You have 6 times 3 minus c times 3 plus c. Now, we're going to have to multiply those. So I'm going to go ahead and do that. We have 3 times 3 is 9. And then 3 times, that's 3c, and that would be negative 3c. So those cancel out. Minus c squared. And then you got 5 times, and here you're going to have 3 plus c. And here you're going to have 5 times, and it's going to be 3 minus c. All right. 3 minus c. That almost looks like a 4. How about that? That looks better. All right. Use the distributive property. 6 times 9 is 54, and then 6 times negative 6c squared. All right. And then 5 times 3 is 15. 5 times c is 5c. 5 times 3 is 15. And then 5, that's going to be minus 5c. Okay. Now, we got to clean this up and write it in standard form. So let's take a look. 5c and negative 5c, those cancel out. And we got 15 plus 15, that's going to give you equals 30. And you got 54 minus 6c squared. All right. So let's see here. Let's add 6c squared to both sides. And you got 54 equals 6c squared plus 30. And let's subtract 54 from both sides. And you end up with 0 equals 6c squared. And that's going to be minus, that was supposed to be 30, minus 24. Minus 24. And if you look, you can take 6 out of both sides. So you got 6c squared minus 24. If we can take it, that gives us c squared minus 4. And then c squared minus 4, that can be factored. So it becomes 6 times c minus 2, and then c plus 2. So c minus 2. All right. And then we got to set each of these equal to 0. So you got c plus 2 equals 0, and c minus 2 equals 0. Subtract 2 from both sides. You got negative 2 and positive 2. Okay. -2 and +2. There are no extraneous solutions. 2 and -2 are not extraneous, are not excluded values, so they can't be extraneous solutions. No extraneous solutions. And the solutions are C equals -2 or C equals 2. Now remember we said that the solution C equals -2 is unreasonable because the speed of the current cannot be negative. But the solution C equals 2 is reasonable because the speed of the current can be positive. If the speed of the current is 2 miles per hour, it would take Kelsey 5 hours to go upstream. Now, how did I get that 5 hours? How did I get 5 hours? Well, upstream, remember, was 5 divided by, and then 3 minus C. Well, C was 3 minus, the current is 2 miles per hour. So 2, well, what is 3 minus 2? That's 1. 1, so that's 5 over 1, which is 5 hours to go upstream, and 1 hour to go downstream. And that's because you have 5 over, and that's 3 plus 2. 3, the current is 2, and that gives you 5 divided by 5, which is 1, which is a total of 6 hours. Why does the domain of the variable have to be restricted in real-world problems that can be modeled with a rational equation? The variable must make sense in a real-world context. The speed of the current cannot be negative or 0. 0 would be still water. So the domain had to be restricted to positive real numbers. All right, let's try another one. I think this one's yours. This one's yours. Your turn. Kevin can clean a large aquarium in a tank in about 7 hours. When Kevin and Laura work together, they can clean the tank in 4 hours. Write and solve a rational equation to determine how long to the nearest tenth of an hour it would take Laura to clean the tank if she works by herself. Explain whether the answer is reasonable. It's a pretty cool tank right there, isn't it? I hope they ain't cleaning that bad boy. So what is Kevin's rate? Kevin can clean 1 tank in 7 hours. All right. And Laura can clean 1 tank in, we're not sure how long. Okay. It doesn't say. We got to figure that out. So T is the time needed to clean the tank. All right. Now, so you got Kevin plus Laura, and you got 1 tank, right? All right. Now, how long did it say? It said it took them 4 hours. It said 4 hours. 4 hours. So we're going to multiply that by 4. Okay. Their rate times 4. Okay, good. Well, what's the excluded value? Well, t here cannot equal 0. Okay, because if it equals 0, then you have undefined. The least common denominator, well, we have a 7 and a t in there, so the least common denominator is going to be 7t. The least common denominator is 7t. So what we're going to do is we're going to multiply everything by 7t. So we got 1 over 7 times 4 times 7t plus 1 over t times 4 times 7t. and then 1 times 7t. All right, what can we get rid of? We can get rid of the 7's here. Good. We can get rid of the t's here. Good. So you got 1 times 4 times t, and that's going to give you 4t. You got 1 times 4 times 7, that's going to give you 28. And over here you have 1 times 7t, which is 7t. Let's subtract 4t from both sides, and you got 28 equals 3t. Divide both sides by 3, and you got 28 thirds equals t. Okay, so that's going to be 28 thirds hours. 28 thirds hours. Well, 28 thirds is 9, that's 20, 9 and 1/3 hours, or 9 hours and 20 minutes. 9 hours and 20 minutes. Good. Why is it important to check solutions to rational equations? Well, you want to make sure there are no extraneous solutions. Make sure no extraneous solutions. Why can extraneous solutions to rational equations exist? Well, when you multiply the least common denominator through the equation, you eliminate the information that limited to begin with. Okay, so let's see, because the process of multiplying through by the least common denominator may eliminate the information about excluded values. And what does that exactly mean? We can't go back. Let's go back here. Look at here. What did we do here? You had a 7 and a t in the denominator. Well, we multiplied through by the least common denominator, and look, there's no longer a denominator. So that wiped clean that it couldn't equal 0. Okay, that wiped clean. There was no more evidence that t could not equal 0. That's what I'm talking about. Essential question check-in. How can you solve a rational equation without graphing? Well, you can do it algebraically. You can do it algebraically by multiplying through with the least common denominator. And multiplying each side of the equation by the least common multiple. When the equation is simplified, the result is a polynomial equation that can be solved. Without graphing, you can do it algebraically. By multiplying through by the least common denominator, which results in a polynomial equation that can be solved Great lesson. Thank you very much, and see you tomorrow in school.